From Algebra 1, we talked about quadratic equations quite a bit. And what we're going to find is in a lot of our homework problems, they are still going to incorporate these equations because we're supposed to know how to use them. So I want to do a quick review as to what quadratic equations are. Quadratic equations have an x squared term. Whether it's x squared and an x and a constant term, doesn't matter. As long as there's an x squared in the problem, it's considered a quadratic equation. The quadratic term is always the term that has our variable squared. So even if this wasn't x squared, it could be a squared, z squared, m squared. As long as there's a term or a variable that has a squared with it, that's considered our quadratic term. The term that has that invisible 1 as its power, that's our linear term. And the part of our equation that doesn't have any variable is considered our constant term. If we want our quadratics to be in the standard form, it's always the squared term first, then the term to the first power, and then the constant. So the quadratic term, the linear term, and then the constant term. When we solve for quadratics, you're solving the variable, and it ends up being 2 answers because it's to a highest power of 2. So we're going to look at this quadratic equation again. X squared plus 7x plus 12 equals 0. Now, the easiest way to solve a quadratic is to plug it into the quadratic formula because no matter what, you'll always get an answer. However, when you look at a quadratic equation, there is another way that you can solve, and most of the time what we're going to come in contact with is the factoring method. It's going to allow us to undistribute or unfoil our binomials, so our two-termed problems, that did multiply together to get me this. So what I need to think about is if I want to foil this or unfoil it, what times what is x squared? In our first position, x times x, if we multiplied it back together, would get us x squared. I then have to figure out how to get the 7x. Well, the 7x is supposed to be a combination of our last terms multiplied together added with our middle terms. So we need to figure out what these two numbers are. The last number comes from the multiplication of these last terms. So what times what gives us 12, but we need to make sure it adds to 7. Well, I could go through the list. 1 times 12, 2 times 6, 3 times 4. All of these are considered our factors for 12. If I added 1 and 12, it doesn't get me 7, actually gets me 13. If I added 2 and 6, it gets me a little closer, but 2 plus 6 is 8. So I can see the only choice I have is if I add 3 and 4 together, it gets me 7, and 3 times 4 is 12. So a positive 3 and a positive 4 are the values that I multiplied together to get 12. But when I check and I make sure that I still get 7x in the middle, 4x, 3x, add up to 7x. So I know that I factored this correctly in order to solve this equation. Now what I want to do, that I have it factored correctly, we're going to use what's called the zero product property. And we end up with x plus 3 equals 0 and x plus 4 equals 0. One-step equations. Subtract 3 and you end up with x equals 3 as one of the answers. When we subtract 4, we end up with x equals negative 4. So again, x equals negative 3 and x equals negative 4 are the solutions for this original equation that we started off with. You can check by plugging them in. If you're not sure if these are the right answers, plug them back in. Negative 3 squared, 9. 7 times negative 3 is negative 21. 9 plus negative 21 would give us a negative 12. Plus 12, 0. We know that has to work. If I plugged in negative 4 squared is 16. 16 plus 7 times negative 4 is going to be a negative 28. We again have a negative 12. Negative 12 plus 12 is 0, so you know both of them work. So these are the solutions for this quadratic equation. practice, but I put it in with a problem that we've been working with parallel lines. Now the first thing I want to do is I have our two lines cut by a transversal, and I am going to tell us immediately that these lines are given to us as parallel. So what we want to do is, with our lines, the problem would most likely have directions or a given statement that would say that line A is parallel to line B. And then what we would have is it would ask us to solve for x. So when we look at this, the first thing that we've been practicing is what kind of angles are these if the lines are parallel. So even if the lines weren't parallel, we know that both of these are to the right of the transversal and below our line, so they are corresponding angles. But since we're given that the lines are parallel, we know that lines are parallel, then our corresponding angles have to be congruent. So even though we've got this x squared part here, and this one's only x, we don't care that it's going to have an x. We know that they have to be set equal to each other because that's what the rule tells us. So what we're going to do is we're going to start off the same way we always would. We take our corresponding angles and we set them equal to each other. So x squared minus 8 equals x minus 2. So the same thing we've been doing all along, we're going to do here. But then we have to look and we say, okay, this one's x squared and this one's x, so they're not going to combine. An x squared in the problem automatically means it's a quadratic equation. So what we see is everything's on opposite sides of our equal sign. We've got to bring them back to the same side. So in doing so, let's leave the x squared alone. Let's leave the minus 8 alone. But let's move our x. It's positive, so we're going to subtract. And we're going to move our x back. And when we move the x back, we end up with x squared minus x minus 8 equals negative 2. Negative 2 because that was a minus, so I'm not going to forget to bring it down. Now we have to bring the 2 over, so because it was negative, we're going to add 2 to both sides. Now I did this in a couple steps so that you can see why we're moving everything back. And we're left with x squared minus x minus 6 equals 0. Now this looks like the quadratic equation that we dealt with before. So here's where we need to think, what are the values that multiplied together to give me x squared? What were the values that multiplied together that got me negative 6? And I have to make sure that whatever those values were for negative 6 add together to get me a negative 1 in the middle. We're going to hope that we can factor, so we're going to immediately set up our parentheses. It's still equal to 0. And we think, what times what got me x squared? It has to be x times x. Then we think of all the different factors, what multiplied together to get me 6. Well, I could have had a negative 1 times 6, and that gives me negative 6. Could have had a 1 times negative 6, that gives me negative 6. Could have had a 2 times negative 3, negative 6. Or I could have had a negative 2 times 3, and that gives me negative 6. I need to figure out which of these combinations add up to be a negative 1. If I used this, I get 5. If I used 1 negative 6, I get a negative 5. If I used 2 and negative 3, there's the negative 1 I'm looking for. So it was a positive 2 and a negative 3. Double check. X times x is x squared. X times negative 3 is a negative 3x, plus 2x is our negative 1, and 2 times negative 3 is our negative 6. So before I did anything, I double checked to make sure this was the outcome. Now that I know that this is factored correctly, we do the zero product property, which means take each of these quantities, set them equal to 0. Subtract 2, and we end up with x equals negative 2. That's our one answer. And add 3, and we end up with x equals 3. Double check, plug it right back in. Negative 2 squared is 4. Negative times negative 2 is going to be plus 2. So 4 plus 2 is 6, minus 6 is 0. It works. If I plug in 3, 3 squared is 9. 9 minus 3 is 6. 6 minus 6 is 0. Both of these then are the correct solutions. And both of them would be the answer to what would fit in this original problem. The example that we are going to look at looks very involved. A lot of times when we're given pictures and they put all of our equations in, we have to set things equal to each other that looks like this. I have x squares on both sides, I have x's on both sides, and I have constant terms on both sides. Because I have x squares, I know again that it's a quadratic equation. So I need to bring everything over to one side in order to solve. So the first thing I'm going to do is I'm going to subtract a 3x squared from both sides. And I'm left with x squared plus 7x minus 3. And then left on this side is a positive 3x minus 6. I need to bring the 3x over. So we're going to subtract 3x from both sides. It was positive, so that's why we're subtracting. And now we have x squared plus 4x minus 3. And then we have our equals negative 6. So the last thing I need to do before I solve is I'm going to bring my 6 back over. And I'm going to go ahead and add that. So finally, I have a quadratic equation that I can solve because it's set equal to 0. So double checking, 4 minus 3 is a 1x squared. 7x minus 3x is our 4x. And a negative 3 plus 6 is a positive 3. So here's where we're capable of factoring our quadratic so that we can solve. Now the nice part about this is 3 is a prime number, so there is only one set of factors for 3, which is 1 and 3. This is positive. 1 plus 3 is 4. So x times x was our x squared. 1 times 3 is our positive 3, but 1 plus 3 is our positive 4. So what started off to look like a very involved problem, once we combined everything to the one side, the factoring part's probably the easiest part of the whole problem. Set each quantity equal to 0. Again, that's the zero product property. And when we subtract 1, we're left with x equals negative 1. And x equals negative 3 when we subtract 3 from both sides. And double check. Negative 1 squared is 1. 4 times negative 1 is negative 4. So now we're left with 1 plus negative 4 is negative 3 plus 3 is 0. So that one works. Check this one. Negative 3 squared is 9. 9 plus 4 times negative 3 is negative 12. So 9 plus negative 12 is a negative 3 plus 3 is 0. So we have both of our solutions as negative 1 and negative 3.